Welcome back to our series on introductory statistics. I'm Mark Ledbetter, and this is lecture video 38. We are in section 9.2, and this is part 3, and this is the final part of the review of section 9.1, where we tested the hypothesis for the mean when we did know the population standard deviation, or sigma. Now, once we finish this video, we will get into testing the hypothesis for the mean when sigma is unknown, which is the realistic case, what we usually have to do in real life. So I hope you enjoyed this pre-recorded video. So that was the first one. We took a little extra time to go through that, so we'll go through the next one a little faster, but it is a different problem. So Bill Arthur is a zoologist who studies Anna's hummingbird. Apparently this is a specific type of honeybird called the Calypte Anna. Suppose that in a remote part of the Grand Canyon, a random sample of 6 of these birds were caught, weighed, and released. A random sample of here, this is n is equal to 6. That's what that is. The sample mean is x bar equals 3.75 grams. Let x be a random variable representing the weights of Anna's hummingbirds in this part of the Grand Canyon. We assume that x has a normal distribution. When we see n equals 6, it's way lower than 30. That is a red flag. We have to have, if I see n is less than 30, I need to have a normal distribution assumed somewhere. And if the problem doesn't say it, we can't assume it. Okay? A normal distribution with sigma equals 0.70 grams. It is known that the mean weight, it's not, because as soon as one dies and another is born, or vice versa, this number would change, even if we did have all the birds. So, and as they eat and what have you, each individual bird's weight's going to change. So we don't really know it, but we're assuming that the mean weight of all of Anna's hummingbirds is 4.55 grams. Do the data indicate that the mean weight of these birds in this part of the Grand Canyon is less than 4.55 grams? Use alpha equals 0.01. Okay, so here's the question. Do the data indicate, and that should say that, the mean weight of these birds in this part of the Grand Canyon is less than 4.55 grams. This is our claim. This is going to be H1, and it says the mean weight, so that's mu, and it says less than, so here is a less than sign, 4.55. All right, so that's going to be our claim. And as soon as we see our claim, we know what our hypothesis is. But first, let's look at the requirements. N is less than 30, but X is normally distributed. As long as you say normally distributed and give me a check mark, I'm happy. All right? Hypothesis statement. H naught, mu equals. Now, what does it equal? Well, right here, it tells me 4.55. Okay. Versus our claim, I'm going to switch back to blue, I think it's easier to see. Our claim, we wrote that down as mu is less than 4.55 grams, because that's exactly what it says here in the claim that we identified. Does it indicate, does it mean, does it tell us that the mean weight of these birds in this part of the Grand Canyon is less than 4.55 grams? Test statistics, since we know sigma, it's going to be z observed is equal to, and again, you can use either one. I'm going to use square root of n x bar minus mu over sigma. That way I don't have a fraction in the denominator, which I have to be careful with in my calculator, or calculate it separately and then type in a bunch of digits. Okay, so square root of 6, x bar, we need to find x bar, it's 3.75 minus mu here is 4.55, divided by sigma, and sigma is up here, 0.7. And again, I do second square root 6, close that parentheses, times a new parentheses, 3.75 minus 4.55, then divided by, I close that parenthesis, and then divided by 0.7. And I get negative 2.7994. And remember, I need to go to two decimal places. So I go 1, 2, 3. This value is greater than 5, so I round up the second 9 to a 10, which makes this negative 2.80. Okay. So here, I always want you to draw a picture, and the book asks you to as well. And so I'm going to put my 0 here. This is Z. And then I'm looking at a negative 2.8. And so since I have a less than, I'm going to shade to the left, or less than the 2.8, negative 2.8. Now I'm going to go over to my Z table, clean up here, and then I'm going to go up to my negative 2.8. So can't quite get there, but negative 2.8 is here, and it's negative 2.80. So that tells me that my p-value is going to be 0.0026. Because we're doing less than. Okay. So for my critical region, I have p-value is less than alpha. I just figured out my p-value, 0.0026, less than 0.01. That is true. So true. So we reject H0 in favor of H1. So the decision is reject H0, the null. Okay. So there exists, or there does exist, sufficient evidence to support the claim. Now we come all the way back up here, and we see the mean weight of these birds in this part of the Grand Canyon this part of the Grand Canyon, oops, capitalized, is less than 4.55 grams. Yep. At a, so remember the confidence level and alpha have to add up to 1. So confidence level is 1 minus alpha equals 1 minus 0.99, or I'm sorry, 0.01 equals 0.99 equals 99%. So at a 99% confidence level using a simple random sample of size 6. All right, so we've done 2 problems, but quickly I want to go over what if on the last one we use H0, mu is equal to 4.55, and we just wanted to know if they were different than 4.55. Oops, I didn't write. Let me write this properly so I don't get points taken off. Mu not equal to 4.55. What if, okay? How would this change? Well, my test statistic, same. Z observed equals negative 2.80. Okay. But p-value. Now, when I draw my picture, because it's a two-sided test, or two-tailed test, negative 2.80, and remember that this is 0.0026, but now we don't care if it's a negative 2.8 or if it was a positive 2.8. So we're just going to have the same area. So we want to add these two together, so the p-value equals 2 times 0.0026 equals 0.0052. And so our rejection criteria or region or critical region is p-value, that's messy, less than alpha, 0.0052 less than 0.01. It's still true. But you see how it could change because you're multiplying your p-value times 2 if you're doing a two-tailed test. So we would still reject H naught. Conclusion. If we get the same, the conclusion would be almost the same. Let me actually, so what would happen is that in the claim, instead of less than, we'd say is not 4.55 grams. So everything else would be the same. The wording of the claim would be different. All right, so that concludes our review for today. I hope this helps you with the homework that I'm going to assign. This is, again, helping you for Section 9.1. Next time, we will look at Section 9.2. Well, that's the end of this video. Please remember to scan your lecture notes before midnight of the date listed on the course calendar. If you have questions, please come to virtual office hours. I am very happy to help you, as always. If you can't do that, then you're welcome to email me. But when you email me, I need 2 things from you. The first is a picture of the problem so that I can help you through email. I may not have the problem available to me. If you don't send me the problem, then you're going to have to wait until I get back to my computer and get that problem pulled up. So please send me a picture of the problem. The second thing you need to send me is a picture of your work so far. This helps me understand how you're approaching the problem and may help me or will help me help you faster and better. So I hope you will stay safe and take care of yourself. Until next time, we'll see you then.